This presentation will look at an introduction to electrical energy. As you've already learnt earlier this year, all matter is made up of atoms. Each atom contains electrons, protons and neutrons. The protons and neutrons are in the nucleus, or the tight centre or the middle of the atom, and electrons orbit around the nucleus. Protons are positively charged, electrons are negatively charged, and neutrons have no charge, or they're neutral. A stable atom has the neutrons and protons in the middle of the nucleus, and then the electrons are whizzing around the outside in orbits. Because a stable atom has the same number of electrons and protons, it doesn't have any charge, because the positives equal the negative charges. But sometimes electrons can either be removed or knocked off, or sometimes also extra electrons are attracted to an atom. So when the number of electrons are not the same as the number of protons, there would be an overall charge on that atom. A charged atom is called an ion, and if there's more electrons than protons, a negative ion is formed, because electrons are negative charges, and there's more negative charges than the protons, which have positive charge. Now, electricity is really the result of electrons being moved. There's two types of electricity: static and current. Static electricity is charge where it builds up at one location. Current electricity is where electric charges are moving around. So let's look at static electricity. This occurs when electric charge builds up at one location. So when droplets of water build up charge in rain clouds and the charge reaches a large amount, lightning is seen where the charge is moving between the cloud and the ground. You may have experienced static electricity when you've taken off a jumper at night and seen sparks appear. Also, sometimes when you get out of the car, you can get a bit of a shock, because you've built up a static charge because your clothes have rubbed against the seat, which is often a synthetic material, and that can build up a charge. Now, current electricity. The current electricity is electric charges, or electrical charge that is moving. Now, metals are the best conductors of electricity because their electrons are not tightly bound to the atoms and can move around a little bit. They're a bit free. Electrons move from one atom to another in metals to allow the movement of charge or electric current. So, if we look at electrical item, we know that there's a power cable that goes to something like this fan. And if we look at the power cable and the copper or the metal wire that's in that cable, you can see that the little blue arrows show the trail of electrons passing from one atom to another as they travel through the wire. So their travelling is actually, and their movement through that wire is actually the electric current. Electrical circuits. An electrical circuit is a path. In other words, you've made this wire and the other little components like the lamp and the switch, they make up the path. So it will leave the one end terminal of the battery and end up at the other. And electrons will leave at the negative end, which will be the black wire, and they will travel around to the positive end, which will be the red wire. So in the picture above, the battery has a negative and a positive terminal. When a wire is connected, each terminal, the wire is connected to the lamp. The lamp glows because electricity or electrical charge is passing through the lamp. As electrons pass through the lamp, they let out some of the energy that's given to them by the battery. The battery charges up electrons with energy and sends them around the circuit. The name for this energy that electrons have in a circuit is called voltage. Now, when we make electric circuits, we can use a number of symbols to show various things that are in the circuit. And here's a few common ones. So we can use these to show the various things in the circuit and how we're going to put it together. The circuit you saw before, which had the battery and the switch and the lamp, you saw the picture of that. Well, here's a circuit drawn out in a circuit diagram. So we've got our battery at the top, we've got our switch, which is this little open line here, which can of course close and the circuit will be on, and there's our little cross in a circle representing our like load. So an electric circuit always has a path for the electrons and then any components that are within that path.